1, 0. Mission liftoff. Falcon 9 with the DART mission on the way for humanity's first ever planetary defense test mission.
The first and second stage of Falcon.
The Imaging X-ray Polarimetry Explorer, or IXPE, will study X-rays from some of the most extreme objects in the universe, like black holes, in a new way. IXPE will look at a special property.
We also really are discovering new things about the universe and where we all came from. This is not in terms of life. I mean, where do stars come from and galaxies and all of that kind of thing. As we explore these other parts of discovery space, we find new things, really things that nobody ever thought about before. And one area of discovery space that's been waiting since the 70s is polarization in the X-ray band. Okay, and there was measurements of polarization from something called the Crab Nebula in the 1970s, and that's it. In orbit will be IXPE, which has a detector which is 100 times more sensitive than that one, and it can open up the X-ray, the polarized X-ray universe. It's probably not going to make us a new widget or anything, but it's actually going to give us another aspect on what's going on.
With polarization, we can find out things which we just can't see with a normal telescope. And so, although we can see the shapes of X-ray sources in the sky and guess what magnetic field orientations exist there, what shapes magnetic fields exist, this is essentially speculation. Until we make the measurements, we can't be sure of this.
The sources we really want to look at, the really close regions around black holes and neutron stars, where there's really extreme physics. We can't image those yet. But if we use this quality of light, that it's not just got a direction, but it's got a kind of plane in which it's traveling. And that plane, that polarization, tells us something about the shape, about the geometry of the source that we can't image.
The things we see in X-rays in the universe are the most extreme types of objects. The environments in which they exist can't be recreated on the Earth. So by studying them, these extreme environments in space, we can test our theories at very high energy densities or very high magnetic fields that are just unachievable on the ground.
If we get one of these sources going off that's bright enough for this new telescope to see, it should be able to test that model of whether the material is wobbling around the spin axis before it slides down below the event horizon and is lost forever.
They're very important if we're going to make use of fusion energy as a new clean source of power, where we will control the plasma with magnetic fields. And so understanding how matter behaves in strong magnetic fields, it's of importance in fundamental physics, but there's also potential payoffs